In our last lesson, we learned how to graph two linear equations known as a set of linear equations, and our goal was to find the solution, where we found the point of intersection if the lines crossed over. Today we're going to find the point of intersection without graphing, and we're going to do that by using a method called substitution. The math involved today is math we've done before. We've substituted and evaluated equations and expressions before. So the math involved is nothing new. We're just going to have to do it over a longer period of time because we have two equations to look at. At the end, our answer will tell us what x and y values make both equations true. And I'll show you what I mean by that. So let's get started and look at the first set of equations. In equation 1, we have y is the same as 20, or y equals 20. Equation 2 is y equals 5x plus 5. Now at some point on a graph, those lines would cross over. We're going to find that without graphing them out. So I'm looking at this and I'm thinking to myself, okay, so y in equation 1, the y is the same as 20. That means wherever I see a y, I know that that y equals 20, and I could replace y with 20. So what I'm going to do is I'm going to replace the y in equation 2 with 20 because y is the same as 20. So I'm going to write it out like this. 20 equals 5x plus 5. How did I get this? I replaced this y with 20. Now, you'll notice I started down here with two variables, a y and an x in the equation, and now I only have the x. So I've just substituted the y with 20, and now I can solve this equation to figure out exactly what x equals. So the way we'll do that is we'll subtract 5 from each side. So all of this is math we've done before. I get 15 equals 5x, and then divide both sides by 5, and we can see that x equals 3. So I now know that x equals 3. I already knew that y equals 20. So my answer is 3, 20. This is the point on a graph where equation 1 and equation 2 would intersect. The 3 and the 20 also make both equations true. So I'll show you what I mean. That's our x value and that's our y. Well, in equation 1, we said y equals 20. If I replace this y with the y value we have, I get 20 equals 20, which is true. If in equation 2, y equals 5x plus 5, I replace this x with 3, and I replace the y with 20, I end up with 20 equals 15 plus 5, 20 equals 20. True again. So the 3 and the 20 made both equation 1 and equation 2 true. That's how I can prove that I've got the right answer. I'll do a couple more so that we can get used to what we're doing. So in problem 2, we have equation 1, y is the same as 30. And in equation 2, we have y is the same as 10x minus 20. So I'm going to substitute the y in equation 2 with 30. And the reason I'm doing that is because equation 1 is literally telling me y can be written as 30. Y is the same as 30. So 30 equals 10x minus 20. Again, you'll notice now I only have an x variable, so I can solve that equation to find out what x is. So I add 20 to both sides. I simplify to get 50 equals 10x. And you can probably figure out from here, if I divide both sides by 10, I've got x equals 5. So I now know that x equals 5, and I know that y equals 30. So that would be 5 comma 30 is the point on the graph where both those lines would intersect. And those numbers make both equations true. So for example, in the equation y equals 30, I replace my y value with 30, and I get 30 equals 30. True. In equation 2, y equals 10x minus 20, we already know that the y is 30. We know that the 10 is 5. And when I simplify this, I end up with 30 equals 50 minus 20, which is 30 equals 30. Again, that's true. Let's look at a similar problem, but slightly different. So this is the same idea. Now in equation 1, instead of saying y equals 30 or y equals 10, a constant, a number that's easy to use, it says y equals, or y is the same as 5x plus 34. And in the second equation, it's saying y is equal to 3x plus 18. We can do this the same way we just did the other two problems. I'm going to replace this y with 5x plus 34 because y can be written as 5x plus 34. So 5x plus 34 equals 3x plus 18. Again, I just substituted, so now I only have the x variable left, and I can go ahead and solve the equation to find out what x is. So I would subtract 3x from both sides. 2x plus 34 equals 18. We'll then subtract the 34 from both sides. I end up with 2x equals negative 16, and divide by 2, x equals negative 8. Now in this case, I still don't know what y is. I don't have an exact amount for y, but I do now have an exact amount for x. So what I'm going to do is I'm going to take my x value, I'm going to take this right here, and in equation 1 or equation 2, it doesn't matter which one, I'm going to substitute the x with negative 8. Personally, I kind of like the look of equation 2. I'm going to use that one, but I could use equation 1 if I want. So I'm going to try to find out what y is. I'm going to replace the x with negative 8. And now, look, we only have a y variable left. So I'm going to go ahead and solve that equation. And I get y equals negative 6. So my answer here is -8, comma -6. Don't forget the parentheses. There's our final answer. And if I was to go ahead and replace the x and the y's in equation 1 with -8 and 6, I would see, as in the first two problems that I did, both equations would come out to be true statements. We'll try this 2 more times, and then you can get working on the practice. So again, I've got an equation that says y equals 4x plus 11. So I know that y can be written as 4x plus 11. And I'm going to replace the y in equation 2 with what y can also be expressed as, which is 4x plus 1. 4x plus 11 equals 2x plus 3. So I've got just x variables left. I'm going to simplify this, or solve the equation. So I'm going to subtract 2x from both sides. That leaves me with 2x plus 11 equals 3. I'll subtract the 11 from both sides. 2x equals -8, and divide by 2, x equals -4. Now I know exactly what my x variable is. I can go ahead and substitute that to find out the y variable. So I can choose either equation 1 or equation 2. Personally, again, I like the look of equation 2, so I'm going to replace this x with -4. So y equals 2 times -4 plus 3. And now we'll simplify this to determine what y equals. So y equals -8 plus 3. Y equals -5, and we're done. My answer is -4, comma -5. So one last example, a little twist on the problem. Again, I have two equations, and I'm going to do exactly the same thing. This looks a little different because equation 2 says 4y equals 28x plus 72, but it's still the same idea. I'm going to replace this y with 5x plus 2. So in equation 2, we have 4 times y. So in this case, it's going to be, after substitution, 4 times 5x plus 12 equals the 28x plus 72. So I replaced the y with 5x plus 12. Now we're going to go ahead and we're going to simplify and solve. So here we're going to have to do distributive property. So there's 20x plus 48 equals 28x plus 72. I'll subtract 20x from each side. That leaves me with 48 equals 8x plus 72. Subtract the 72 from each side. And I'm left with -24 equals 8x. Divide by 8, x equals -3. There's my x value. I just now need to determine what y is equal to. In this particular problem, equation 1 seems the easier one to now use to find out what y is. So I'm going to replace this x with -3. I'm replacing the x in equation 1 with -3. Y equals 5 times -3 plus 12. Simplify the right side, and we've got -15 plus 12. And when I simplify again, I get y equals -3. So in this particular problem, my answer is -3, -3. So that's system of equations. It might seem like a lot, so take your time as you go through these. Refer back to the video as you're solving the problems in Mathspace. And feel free to use a calculator to help you with multiplication and addition, but really focus on the substitution part. If you have any questions, email me, and I'll get back to you as soon as I can.